to make the decision. So what this means for the pipeline is we basically have the Direct3D pipeline. This is what we had for Direct3D 10. And we're just going to add 3 new stages for tessellation. There's the hull shader and the domain shader, and those are both programmable stages. And those are sort of sandwiching that fixed function tessellator. Now, unfortunately, I don't have time in this talk to explain what each of these stages does, and I'm very sorry about that, but we only have the time that we have. The important thing to understand is that while I am going to talk about features that will work on down-level hardware, on Direct3D 10 hardware, this is not one of them. It requires Direct3D 11 hardware. It's just too slow to do in software emulation. Okay? The other interesting thing to note is that the fundamental primitive here is a patch, because again, we're getting closer to the sub-D surface. And it's a superset of Xbox 360 tessellation. And what this means is that basically, again, we're really trying to make that cross-platform development experience better by, providing what you could already have on the Xbox 360. We have that functionality too, but at the same time, we're taking advantage of advancements that have been made in the PC hardware and graphics ecosystem since the release of the Xbox 360, and also building upon our knowledge and experience of what worked and maybe didn't work so well with the Xbox 360 tessellation. So we're still reproducing that functionality and building upon it. So here's some sample images. These come from the November SDK. All the stuff that I'm talking about is in the November DirectX SDK, and I'll talk about when that becomes available at the end of the talk. We have our fabulous clown model here. And so this is the first level of detail, the first tessellation level. This is level 2. Level 3 subdivision. This is actually now level 5. We skipped 4 just to make it more interesting, and all the way up to level 7. I just want to tell you a little funny story about this, which is the art guy who's the content manager. He came in when he's like, look, I've got the clown. And everybody on the dev team was like, I hate the clown. So the clown's actually going away for March SDK, but you're stuck with it for November. So the way I like to think about tessellation is it gets us closer to eliminating pointy heads, right? And this is the thing, if you're a gamer like me and you zoom in close to your character, God, it's so distracting. You start seeing like the creases in their head. More formally, what this is doing is it's scaling visual quality across PC hardware configurations. Again, we talked about, PC hardware configurations meaning different graphics cards, meaning different display resolutions. It also supports performance increases in 2 ways. First, this coarse model really is a form of compression, right? It means faster I/O from disk to main memory and across the bus to the GPU. And again, rendering can be tailored to each end user's hardware. We don't need to render stuff unnecessarily if the display is small. Or again, if we notice that frame rates are dropping, we can just make the choice to decrease visual quality in favor of consistent frame rates. It's also, again, getting back to that idea of cross-platform experience with Xbox, Windows and Xbox. And finally, I think the important thing is we're just getting closer to rendering the content as the artist created it, right? And that's really what people want, okay? They don't care when you're looking at somebody's, 3D, whether it's a game or something else. You don't sort of care the technology. You just want it to look good, and that's what the artist is all about. And we want to enable the artist to do that. Now we're going to talk about another feature, multi-threading. And multi-threading today, a very common scenario is you might have your physics simulation running on one thread, your AI simulation running on another thread, and the graphics portion of your app running on a third thread. And that, of course, is what's talking to the GPU. But there's a problem if it's the CPU-bound, if it's the CPU-bound portion of your app that's really holding things up, right? Basically, the little hamster on the CPU is running as fast and fast and fast as it can, and meanwhile, the GPU is just waiting idle for something to happen. And we're getting closer to Halloween. For us in the graphics team, that's a nightmare, right? That's like Nightmare on Elm Street. The GPU is waiting idle. So we want to do everything in our power to make sure that doesn't happen. And what we're doing is we're enabling multi-threading then, or improved multi-threading, I should say, on Direct3D 11. It was available in Direct3D 10, but we're improving it in 11. And basically what we're doing is we're enabling distribution of the application code, of the runtime, and of the driver across threads. We're also providing an immediate context. That's the thing that talks to the GPU, plus deferred context. And what the separation does is it enables an application to, say, load a texture or compile a shader on one thread in such a way as to not significantly impact the rendering portion of the app. In addition, we've made object creation entry points, free-threaded. So you can have many threads creating objects simultaneously. And again, for those of you familiar with Xbox 360, this basically enables the same scenario as precompiled command buffers. Now again, in terms of key takeaways, one thing I really want people to understand is that Direct3D 11 multi-threading will work on Direct3D 10 hardware. And so we definitely see significant utility for this. We see a lot of people just right out of the gate basically doing Direct3D 10 plus the 11 multi-threading because there's no reason not to. It's going to work on the hardware that's out there. So the following now can be distributed across threads. That's the upshot of this. The application, of course, the 11 runtime, that doesn't change. The 11 drivers, and if your friendly neighborhood IHV chooses to provide an updated driver, that can also take advantage of the multi-threading on 10 and 10.1. But saying it this way is a little bit confusing. So let's go back to our architecture diagram. And so here I've shown the application and the Direct3D 11 runtime, because that's what we're talking about now. And they have this sort of nimbus, this glow around them that's supposed to represent multi-threading. I didn't know how else to do that. So they're multi-threaded. They're talking to the 11 drivers. These are the new drivers for the new hardware. Those are also cognizant of the multi-threading capabilities, so they're also distributing themselves across threads, and that talks to the 11 hardware. But it will work with your existing 10, 10.1 drivers and hardware. So that's super important to understand. However, if the IHV chooses, they can release an updated driver that will also be able to take advantage of this multi-threading. Okay? So it works great on the existing hardware and drivers, going to work even faster on the newer hardware and drivers. The whole point of this feature is to improve performance, of course, and we see it when we're thinking back about what does Gamer Corp care about, and they care about scalability and performance. This is scalable in two ways. The number of CPUs, of course, that's the whole point of the feature, and also, again, these graphics cards and drivers. It's going to work on the existing stuff today. It's going to work better and faster on the newer stuff. Let's see how we're... So dynamic shader linkage. Shader issues today. Sounds like a magazine or something. Thanks for your pity laugh down in front. I appreciate that. So shaders basically are getting bigger and more complex, right? Again, our expectations for how graphics look are just going up and up. They don't decrease, they only increase. So now we have, more complicated subsurface effects, more complicated material properties, more complicated lights, more material. I mean, all this stuff. It's just getting bigger and bigger. But again, shaders need to target this wide range of hardware, right? Even within Direct3D 10, there's a wide range of capabilities and performance. So what winds up happening is that developers wind up optimizing their shaders to take advantage of these different configurations. Right? They wind up just spending a lot of time just tuning these shaders to plan for all these contingencies.